A very good afternoon, all of you. Am I audible?
Yes, clear.
Hello.
Yes, loud and
Am I
clear.
audible?
Yes, ma'am.
Okay, okay. So our session will be start within 1 or 2 minutes. So please, I just request all the participants, please fastly join the session because our guest is here. A very good afternoon, all of you. Hello.
Yes,
Good
ma'am.
afternoon, madam. Good afternoon.
Okay. So I'm Professor Pipi Thorat, welcoming all the participants behalf of Dr. Bapuji Saunke Institute of Engineering and Technology. So basically today is the last day of FDP and the today's highlight point is policy, standards and global perspective for hydrogen energy. And our today's guest is here. Firstly, I just introduce today's session leader, Mr. Dr. M. Srinivas sir. Welcome sir. Firstly, I just introduce him shortly. So basically, during 2013, Sir completed his Master of Science in Nanotechnology. In 2019, Sir completed Doctorate Philosophy in Chemical Engineering. He also worked as an postdoctoral researcher. In 2023, Sir worked as an assistant manager in Neogen Chemicals, Gujarat. Currently working as a project manager CSSM, Cheng Shiu University, Taiwan. So various publication on his name like Sustainable Hydrogen Production, Journal of Hazardous Material Advances. So warmly welcome, sir. We just all are grateful to listening you. So I just humble request to you, sir. Please start your session.
That was a very nice and interesting introduction from your part, from your side, and I'm very much honored and thankful for this session. And I'm really glad and to sustain this presentation and with the by welcoming to the students. A warm welcome to all of the students. As per the introduction which you have received, myself, Dr. M. Srinivas. So currently, I am working as a project manager in the Department of the Environmental, Toxic and Emerging Contamination Research, National Changsha University in Taiwan. So today's my session. I would like to discuss about the policy standards and the global perspectives for the hydrogen energy. For that, I would like to go introduce about my center, how my center is working and what kind of products we deal. So as I said, the center is completely based upon working on the environmental toxic and also the contamination research, and we are also going the stepping stone for the new and renewable and sustainable energy in coming days. And these are the center which was established in 1999. It is the first dioxin. So I hope some of you are aware and some of you might not be aware about the dioxin. Dioxin is a chemical drug which is available, which is able to present in the dietary products. So this is very toxic, and because of this toxic chemical which is present in the dietary systems, and which can we can say very carcinogenic contaminations which will be very harmful for the human body system, and also it will damage the entire multi-organal disorders. So we would like to identify such a toxic chemical in the dietary and the food products, and this is the first lab in Taiwan which was established in 1999. And further, the center was named as the Center for Environmental and Toxic Emerging Contamination Research Center. And from that, we received some kind of the certification from the Ministry of the External Affairs, Taiwan Research Government, and the European Research Council. And these are the international achievements and the cooperations that we have received from the beginning of the 1999 to 2022. And still the lab is working for 15 laboratories from the worldwide for the infant and food accuracy measurements, to analyze the milk powder, to analyze the soil and ash samples. And also we have a sustainable corporations internationally, including NASA, Nexus, Navitech, and Energy, and Califa, and BK, and Argentina. Also, we have several corporations around the world. So these are the worldwide contributions and the international corporations that we had. And the organization structure is having the three kinds of the teams like Supra, Micromass, and Biotechnology, and the External Purification Bio Research Center. So these three departments will collaborate together and working for the International Cooperation Group, Technical Research Center, and R&D Group, and also as well as industrial service sectors. So all these departments will try to work with the existing technologies and existing methods that which has been available, and we receive the samples from worldwide from the companies of Taiwan, Asia, as well as the other international customers to analyze the contaminant, to analyze the products, and we release the quotations and we detect as a QC and QA R&D division, and the sustainable methods we will deliver the products to the concerned department. Right now, the next step, we are going to stepping forward to establish the sustainable energy technologies to establish 1 kilowatt to 1 gigawatt sustainable energy hydrogen energy generation plant, which is going to be occupied in next coming years. And these are the samples that we collect from air, we collect from the soil, we collect from the several various plants, industrial plants, and after we receive the samples, and we have a HP mass, LC mass, GC mass, and the tandem mass, all these analytical methods and techniques, we usually analyze the products, and these products we used to deliver for the sustainable methods for the Department of the Environmental Science Boards to for their verification and their validation. And coming to our topic, the first we start our lecture is going to begin from here, that we would like to discuss about the hydrogen revolution. Why we start this hydrogen revolution? A beginning stepping stone, a net zero carbon goal emission, which is going to be acquired in next coming future days. Why we need to begin this one? Because of the drastic the climate change that we are going to see, observe, a serious threat for the human survival. And for this reason, the world population is also still growing more, and also the current energy demands, which is not suitable by using the renewable energy sources, like for example, burning the coal and getting the energy is not at all a sufficient method, since the population is growing very high, almost drastically 9 billion population by the next 2050. So the developing economies still they need a sustainable growth. And also the environmental also will be a drastic contamination because of the fossil fuels that we get observed by using the CO2 emissions that we receive from the renewable energy sources. So the urgent action that we need is the drastic CO2 in air, which is keep on rising increase, which is like to push like global warming. And from beginning of the 1988 to 2025, almost like 1.5 degrees centigrade which was drastically increased. And because of this reason, we are observing how our climate is going to be changed. We are having a sudden typhoon, sudden monsoon, sudden rain, which is going to be a global threat, and increase of the temperatures, and also increase the most of the icebergs are going to be melt, and also the sea level is also going to be increased. All these climatic actions that is going to be observed in recent days. And because of this increased CO2, as we can see, the death rolls among the world population by using the air pollution, water pollution, and also the toxic chemical pollution. We can see the death tolls around the world, and also we can observe around like 135 millions of the premature deaths was happening because of the rise of this environmental greenhouse gases such as CO2 and carbon monoxide gases emissions. So from the beginning of the 2019, around like 40 billion tons of the CO2 which was released, and this number is not stable. This number is going to increase drastically. And the global warming around the, as I said, like 1 degree is much more hotter than from the beginning of the 1880, and driving which is faster and weather harming, which is threatening to the people. So if these emissions increases from 1 degree to 4 degree, if we don't taking any action, definitely by 200, 2100 makes many places in this world very hard to live. So the first step is like melting of the ice sheets, and also the releasing of the methane can speed up this process very easily and very effectively. And coming to this non-renewable energy, how the pollution is going to be enhanced by the various sources. As I said, if you burn the coal, the highest greenhouse gas emissions, about like 820 CO2 per kilowatt hour, is going to be released. And the death rate is almost like 25 deaths per terawatt hour. You can see the terawatt is like almost 3 million, like for example 3 lakhs is considered as 1 terawatt, and 1 terawatt is equal to 3 lakhs homes per year. So for every 3 lakhs homes, we can see 18 deaths can be observed, and almost like 25 deaths can be enhanced by this generation of the CO2 gases. And also the toxic chemicals like, for example, mercury, arsenic, and nitrous oxide, sulfur oxide are also very drastic, which is going to be harm for the environment. And also the oils which has various pollutants which is going to be spill over in the oceans, that can also be harm for the environment. And also for the extraction of the natural gases also leads to the death tolls, as well as the exploration of the nuclear, and also the nuclear exploration for the nuclear power also will leads to the drastic change. What are the methods that we follow? For example, the fossil fuels, almost like 70% of the global CO2 emissions, these are the responsible cases, like oil, coal, natural gas, and nuclear material like uranium to the arsenic. These are all the case of the systems which is going to be enhanced these global CO2 emissions. And coming to the natural gas, coal, and the renewable energy consumptions, so there are like various countries which they are going to depend from the beginning of 2022. Here we can observe the increase from 2022, increase from India is about like 8%, and ranging from China, United States, Russia, Brazil, and Japan, almost we can see the drastic scenario. And coming to the coal, the India percentage is 10% of the consumption, and also China is 5%, and the Russia is almost like negligible. And also coming to the renewable energy sources, we can see the country which drastically using the renewable energy sources is China, and the next followed by the Brazil, and next followed by the India, Russia, and also European Union, Japan, and as well as United States. And future energy demands on this energy is basically expected to reach about, like as I said, like 9.7 billions by 2050, and which is going to be intensified by the global energy needs. And there is a rising demand for the energy consumption to be grown by 30 to 50% compared to the today. Shifting, we are going to be shift because of the energy demands to the clean energy, and also to reduce the global warming and to reduce the CO2 emission. There is a serious transition from the fossil fuels to the essential sustainable energy sources. So for essential sustainable energy sources, we have the key drivers looking for the renewable electrification, green hydrogen, and energy storage systems. Without these clean energy adoptions, the emissions could push the global warming beyond 1.5 degrees centigrade to more than 4 degrees centigrade by 2050, and or by 2100 years. Innovative which is predominantly required in the smart by building the smart energy grids, and which is having the crucial efficiency for the carbon neutral technologies and the sustainable future. So the current policies and the global coordination strategy which exists in the present world, the present target is 1.5 degrees centigrade target, but the current policies, the whatever the current policies, the existing policies reach to 2.5 to 2.9 degrees centigrade. If we have the scale bar from 1 to 4 degrees centigrade, the current policies can only do 2.5 to 2.9, but the target is 1.5 degrees centigrade. So this the more efficient policies has to be taken, and more systematic sustainable developments has to be adopted by the various government and institutions, and also the societal awareness also be definitely will be one of the crucial role in the betterment of the society, and also development for the energy demands for the global sustainable pathways. And there are like versatile paths for the net zero carbon emissions. International energy agencies have given the guidelines by 2050 report, which outlines the global pathway to limit the global warming to 1.5 or below 1.5 degrees centigrade. There are key milestones which they have included. One is that tripling the clean energy investments to almost like $4 trillion. As we know, the $4 trillion economy is India is reached the $4 trillion economy by 2025. So the same $4 trillion economy, if we invest for the net zero carbon emissions, for the clean energy sustainable sources, definitely it will be a stepping stone for the future energy demands, and also to reduce the CO2 greenhouse gas emissions. There is a rapid development for the renewable energy sources from the 630 gigawatts by using installation of the solar photovoltaic, solar photo panels by 390 gigawatts for and wind annually. And this energy is not at all sufficient. Still, the energy intensifies. So, still, we need to procure the enhancement of the 4% per year, at least by 2030. So the initiatives are like we need to build a massive scale up in electrification, and also the electric vehicle adoption, green expansion, and hydrogen infrastructure, as well as the net zero carbon buildings. These are the massive scale ups that we can able to initiate by the government bodies and the policy bodies to enhance the betterment of the society. So as I have mentioned the previously, the same variables the International Energy Council has been declared. These are the technologies that we can able to adopt. But the agencies has also mentioned nuclear and the hydropower. Since the nuclear emissions using the nuclear power, the reduction of the CO2 gases can be observed. However, the as I said, there are like many roadmaps, and also the nuclear power projects, they have very less emissions of the CO2. But the purification of the nuclear waste is one of the very challenging aspect. So many of the energy bodies and energy agencies, they are not showing that much interest, because of the purification of the nuclear elements is really hard, and also it's not good for the environment. So people are going with the carbon capture technology, hydrogen energy, which is going to be enhanced for the sustainable future. So this is the International Energy Agencies to the net zero carbon emissions has given the roadmap by to 2050 roadmap. So in the initial phase, as I have discussed, the temperatures has to reduce to 1.5 degrees centigrade by implementing the sustainable energy approaches and the technologies. And the present pledges are critically which is insufficient, because all the government pledges was showcasing their investments based upon the technologies they have adopted from the non-renewable energy sources. But the current energy demands has very high. So because of that reason, the government bodies are also balancing 70 and 30% rule. 70% from the non-renewable energy sources and the 13% from the renewable energy sources. And these are the energy sources that we have from the system of integration from the solar and the wind, hydrogen energy, battery storage, and these are the viable renewable energy sources that currently which is having the existing. The current advantages for the solar is it is like low cost in the electrification in the many regions and also reduce the greenhouse gas emissions. The disadvantages is we can only use the solar panels in the daylight. Coming to the night, it is really challenging to utilize the during night systems, and also the high cost and also the land cost and also the material manufacturing, it is one of the critical challenge. However, if the solar panels are combined with the battery storage for daily balancing, like to establish to connect with the grid, it is also one of the versatile opportunity to balance the renewable energy system, and also the wind energy, which is the operationally low cost, and also it's a mature technology and currently is established, and which also reduce the low emissions. The disadvantage is like it is variably out. The land procurement is a difficult task, and also the maintenance. Also, we need to look forward for the wind energy. But this can be enhanced by using the grid integration and also by combining with the hydrogen energy as for the seasonal backup. And also coming to the hydrogen energy, which is a decarbonization agent and which can directly reduces the CO2, because in hydrogen energy, if we do the reaction process, the byproduct is water vapor. There is no CO2 in the reaction process. And the electrification is also, it is a sea level shipping agent, and the electrification is also very simple. And if we connect to the direct to the grid systems, and it is very viable, and which can be used in a direct approach for connecting to the grid level organization. And the long duration days also it can able to work, and also the facilities, the energy export also quite very well. And also the disadvantage is having the it is having the current existing technologies like materials and the electrolyzers, and which are currently under research, and the efficiency is like 30 to 40%. So as of now, the infrastructure is cost efficient, but in coming days, the cost efficiency can be reduced by enhancing the R&D methods and R&D techniques. And if we combine this hydrogen energy with the battery storage systems, and the generated amount of hydrogen gas which can be connected to the fuel cell, and from that fuel cell the power was generated, the generated power can be stored in the batteries, and which is the charge can be connected to the grid level system, which is one of the efficient method to be used this hydrogen energy for the future energy needs. As I mentioned, like battery storage is also having one of the versatile renewable energy source, since the battery storage materials having a high energy density and also easily charge storage capabilities and a faster charging and discharging methods. But however, the batteries can be only operate at the room temperature, and if the temperature was exceeding since more than 50 degrees centigrade or 55 degrees centigrade, the batteries in the electrolytes present in the batteries, which are really expelled to explode and be a exothermic reaction, and which can able to be so not suitable for the environment for the safety concern issues. But these batteries at room temperature can be used to store the hydrogen energy, and also which is can be used for the connecting to the grid level systems. And as I mentioned, the environmental, there is a nuclear energy is also one of the critical renewable energy system. But however, the processing of the radioactive waste, the spent nuclear waste, is a hazardous for the years. So mining of the uranium is very environmentally impacts and also disrupts the radioactive residues. and also the nuclear plants usage and the amount of the water for the cooling system and the high cost for the long building times, which is also like one of the drastic reduction policies which can be we cannot able to encourage for the future coming years. So from the past 10 years since we have been used, but the next and in the future this is not environmentally useful, and which we are going to be for the energy storage systems, for the sustainable energy storage system. Hydrogen energy is one of the key energy and electrolyzers, and which is used for the net zero carbon emissions. And in hydrogen energy, we use feedstocks for the steel and also used for the cement for the shipping and aviation. Excuse me, is everything is fine? Hello? Hello, ma'am. Is everything is okay? The presentation is okay? Am I audible? Hello? Hello? Hello?
Hello, sir. Presentation is okay, but noise comes from Shraddha Jatpur.
Could you please tell to her anyone to mute her mic? Hello. Hello.
Yes, sir. Yes, sir.
Yeah, could you please tell to
Yes.
turn off the mic?
I am doing, sir.
की महिला आहे का पुरुष आहे मला त्या जेंडर वाईज मध्ये जायचंच नाही, कोणी अधिकारी असो, पण एखादा अधिकाऱ्याला डायरेक्ट उपमुख्यमंत्री कोण हेच मुळात चेक होत असतं.
Yes, yeah. Yeah, let's continue our presentation. Hydrogen energy is one of the viable, efficient method for the net zero carbon emissions. So it is one of the versatile fuel, and also the feedstock is this, the water and the steel, and which is this hydrogen energy can be used in the processing of the steel, cement, and also the shipping and the aviation process. And this the storage of the hydrogen is we can use for the long duration from the weeks to the months, and also which this hydrogen energy can be used as to balance the renewable energy sources. And the functionality of the electrolyzer is which are able to split the water molecule into the separate water molecule is having the H2O. So in the electrolysis system, the hydrogen gas was separated and also the oxygen was separated. So the oxygen gas can be used in the chemical forming process, and also the hydrogen gas also be used to be generate as the fuel, and also the hydrogen gas be used for to making up of the some of the inorganic chemical systems. And we need to scale up this hydrogen gas for the global capacity like more than 1.4 gigawatt by 2023, but according to the international energy agencies it was listed as 560 gigawatt by 2030. So in the electrolyzer systems we have like various electrolyzers. One is alkaline electrolyzers, and this alkaline electrolyzers is which is very cost effective and the performance is like steady. And the other one is the PEM polymer electrolyte membrane, and it is these kind of electrolyzers are the fast and they're like flexible for the if you are going to integrate with the solar and the wind energies. And the efficiency was if we are using these both kind of systems to be connected with the solar, wind, and also the battery systems, the efficiency gains for almost like 95%, and also the cost will be like effective for making the hydrogen production units. As I have mentioned, there are like various utilizers. Not only most of us, we think about the hydrogen gas means we can able to fuel up any kind of the electric vehicles. We can fuel up the power. Irrespective of the fueling the power, there are like alternative applications by using the hydrogen gas, which can be used in the formation of ammonia, methanol, and the refining dominations. And majority of the chemicals and most of the other olefins, fertilizers, this hydrogen gas will be used. And in the hydrogen technology, as from the last 5 days, the students and the faculty members are learning about what are the various kinds of the electrolyzing systems and various hydrogen methods has been involved. But as you are very aware about, maybe you are aware or may not be aware, but I would like to have a glimpse of various hydrogen productions. In various hydrogen productions, there are like named as one hydrogen can be named as various names like green hydrogen, pink hydrogen, and yellow hydrogens. All these having the same kind of the process, like electrolysis process. If you do the electrolysis process using like solar or wind or like geothermal energy, you can name that as a green hydrogen process. If you are doing the electrolysis process using by the nuclear waste or nuclear energy, you can name that one as a pink hydrogen. And if you are mixing this origin with the like electrolysis with water and electrolysis with nuclear, with these kinds of the grid available systems, you can name it as yellow hydrogen process. And also there is another hydrogen called blue hydrogen. So this blue hydrogen, dark hydrogen, gray hydrogen, brown hydrogen, and the black hydrogen, all these names, they will come from the like burning of the fossil fuels. Like when we are processing the fossil fuels, the coal, when we do the hydrolysis process, when we do the pyrolysis process, during the formation of the natural gas, these types of the hydrogens can be classified. And also when we are doing with the biomass gasification like biodiesel or biogas systems, there is also undesigned product of the hydrogen gas also be which can be produced. But clinically and experimentally, and the most favorite and the most encouraging hydrogen energy which can be used for the commercial purpose is a green hydrogen, because there won't be any toxic gases or there won't be any greenhouse gas emissions or combined as a byproduct with other kinds of the hydrogen. When we use in the terms of the green hydrogen, there will be the byproduct will be the water vapor, which is not carcinogenic, which is not toxic, and we can be reuse that water vapor for the further electrolysis process by doing the condensation process. And also, as I would like to go with this kind all information that which I have provided in the previous slide as well. So I'm skipping this one. So now we are going with the electrolyzer compounds. In electrolyzer compounds, we have the various compartments. One compartment we call as anode compartment, and another compartment is as called cathode compartment. So in the anode compartment, we call as a positive electrode, where the water is going to be, oxidation is going to be occurred. In the cathode compartment, it's a negative electrode, like where protons and electrons will combine together and to form like a hydrogen gas. And in the case of the, irrespective of the alkaline electrolyzers, we have the polymer electrolyte membrane, which is also called the solid polymer, which conducts the protons, building blocks for the electrons and also the gases, which these both systems like alkaline and the polymer electrolyte membranes, which can be connected for the external circuit to flow the electrons. The flowed electrons and also the passive, the hydrogen gas can be connected to the fuel cell, and from the fuel cell the energy charge can be dissipated and charge can be absorbed in the external circuit of the fuel cell. At the anode oxidation, you can see the two hydrogen molecules, like two water molecules, splits together to form the one oxygen gas molecules and the four hydrogen gas molecules, and also with the four electrons. These four electrons will combine with the water molecule, and again it will do the pseudo reaction, and the reaction is like a reversible reaction. The reaction will be continuous. And the hydrogen production, which is going to be generated as the gas was continuously generating. So commercially, we have available of the various plants, the electrolyzer plants. The first ideal plant is 1 kilowatt plant. And also in the industrial scale, people will go with 10 megawatt and 1 gigawatt. So in 1 gigawatt, we use the membranes, irrespective of the compartments like anode and cathode, we use the solid oxide electrolyte membranes, which can able to separate the compartments and also do the fast electrolysis process. And in 1 kilowatt process, the carbon-free hydrogen production rate, which is going to be released like 0.02 kgs of the hydrogen, and this is approximately like 50 kilowatt hour per kg. And the source was like electrolysis, which is used like from the ranging from 50 to 55 kilowatt is to produce the 1 kg of the hydrogen gas. In case of the 10 megawatt, the 200 kgs of hydrogen per hour, which is going to be divided by the 50 kg watt hour of hydrogen gas, and which can be directly scale up per energy input. And 1 gigawatt was reported in the most of the countries like Germany and United Kingdom. They are going to be used for like 2,300 kgs per hour, and which is nearly close to the 92 megawatt system, which is scaled for the 1 gigawatt. So you can run completely one city, like most of the majority of the municipalities can be operated, the energy storage can be operated with using the 1 gigawatt hour our energy efficiency outputs. So for basically the commercial electrolyzers like 1 megawatt or 1 gigawatt electrolyzers, basically having the schematic of the electrolyzing systems. First, on the left side, we can observe the water tank, and this water tank which is connected for the heat exchangers. From that, there will be a process water which can be passed to the electrolyzer stacking system, which is having a multiple electrolyzer stacks, having anode and the cathode compartments. Basically, this anode and cathode compartments can be varied by utilizing the various materials. So based upon the efficiency of the nanomaterial, the electrolyzing material, so these electrolyzer stacks can be designed, and that efficient designs can be connected over here. And once the reaction starts, so from the voltage output, basically this voltage output can be given with by the connection to the solar panel. So the solar efficient B also can generate some bias, or this bias can be replaced by, people can use as a nuclear power, people can be used the geothermal power, people use the solar power. The efficient method is like connecting to the solar power to give the applied bias, and which is connected to the electrolyzer stack. And finally, the generated hydrogen gas can be compressed and can be stored in the hydrogen storage tanks, and which can be used as the reliable and readily used, or which can be used for the storage tanks, and which can be further be converted into the fuel cell system. From the fuel cell system, the charge can be stored in the terms of the battery storage systems. So this is about the green hydrogen value chain. So in the green hydrogen value chains, most probably the renewable energy from the electrolysis, the renewable energy sources can be compensated, and which can be used for the transportation, and which can be used for the trucks, and which can be used for the pipelines. And the usage of the steel industry, chemical industries, and the refineries also, these generated hydrogen gas can be utilized. And by using the hydrogen gas, the shippings, aviation, cars, and rail, trucks, bus, all the electric vehicles can be utilized as a source of the fuel, and also as the transport for the building for the next generation chemicals. And also this gas can be utilized for the synthesis of the fuels and the synthesis of ammonia, and also which can be used for the urea process for the agriculturist, also can be used this generated hydrogen gas. And coming to the global perspective of this hydrogen gas, the International Renewable Energy Agency has been given some systematic principles. So the principles are, which we are going to discuss now. The National Hydrogen Energy Agency is having various strategies. In this strategy, around like 30 plus countries are agreed to accepted to process their hydrogen strategies by the International Monetary Fund is one of the financial institution, and IERNA is another financial institutions is going to be run by the East Asia and the West Asia, and also IMF from the United States are also going to sponsor this to establish the global energy hydrogen based plants. Over 30 plus countries has been agreed, and also the 41 countries having roadmaps of how to establish their hydrogen energy storage plants by 2023. They have already given their roadmaps, and also the policymakers from the International Renewable Energy Council, they have raised like 4 pillars. One is the national strategy to define the ambition and mobilize for the investments for the green hydrogen generations, and they support the priorities focus on the key sectors like industry, transport, and the power sectors. And also they are going to be organize the guarantees of the certification and the emission labeling. So what are the if it is a green hydrogen gas, the emissions will be like water vapor, but if they are going to use for another sources like what I said from the environmental concern like pyrolysis or any other kind of the use, so what are the certifications, what are the emission board they are going to give the certification. And also the government and the integrations of utilizing of this energy is one of the 4 policy pillars the International Renewable Energy has been listed. And also there is a investment strategy, like many of the young entrepreneurs, they are going to take this as one of the challenging opportunity to scale up from 1 gigawatt to 1 megawatt onto terawatt of the hydrogen generation systems. And also the industry transport power also be channelized, and which is going to be mobilized. Since we are very much concerned, the recent days, as all you have heard about, Tesla has launched its variation in Mumbai as a first branch in India. And for any kind of the electric vehicle, the support need to be like electrical charging stations. Since for every 20 to 50 kilometers, we can able to see Hindustan Petroleum Corporation or the Bharat Petroleum Corporation to fill our gasoline needs. But if we buy the electric vehicle, are we going to have the charging stations for every 25 kilometers or the 50 kilometers range to power our vehicle all over the India? But this can be the young entrepreneurs, which they are going to have the idea of establishing the gigawatt of hydrogen production plants, and they are going to interlink with the fueling stations like fuel cells stations, the generated gas which be connected to the fuel cell, and further the power can be stored in the battery, which can able to fuel up the charging station to electrify the charge storage capabilities. In for every metric ton to the for every kilometer, we can able to enhance this efficiency all over the India, all over the world, by doing the sustainable development methods, by investing the young entrepreneurships, and also the encouraging the government policies can also lead for this drastic growth. And for labeling the origin of the emissions board also give the liberalized, and also be they have concern for the national development and the national integrity to give efficient and prioritized things for the young investments and the young companies of the those who are going to be commit to this work. And also the strong governance system also be one of the critical part to issue the license, and also to enhance the performance progress, and to monitor their functionality, and to be give the subsidized loans for the entrepreneurs to build the nation of the countries. And these are some of the countries which they have already a roadmap for the sustainable hydrogen strategies. Coming for the North America, the National Clean Hydrogen having the roadmap which was launched in 2023, and they are going to be enhanced the one almost the hydrogen shot is going to be cost to 1 kg be the cost can be reduced by 2030, And the production goals they have mentioned almost like 10 metric tons by 2030, and 20 metric tons by 2040, and 50 metric tons by 2050. And also the regional policies they are going to be enhanced to have a clean hydrogen hubs for every 50 to 100 kilometers, and also the tax credibilities by using the 45 volts, and also expanding the bipartisan support for the hydrogen and the fuel cells. In the same parallel path, the country Canada is also going to be have the net zero carbon emissions in the COP25 meetings summits. So they have also promised by 2050 the hydrogen industry is going to be they are going to enhance in the different departments like transport, power, and also various departments. They are going to bring this innovation to sustainable methods, and also they are going to focus the strong focus to have the export of these technologies for the other nations, to frame up the scaling and the production for the international trade, and to also have the growth in their economy for the sustainable future to enhance their percentage. And also the hydrogen origins in Colombia as well. As we know, from the Colombia, it was started like 2020, the hydrogen refining was started, and the beginning of 2020, they have initiated the buses, trucks, and the passenger cars. Still, the R&D level by using the 2030, they are going to be enhance their electric vehicles by using the hydrogen based, and also by 2030 they would like to use the hydrogen based fertilizers, and also they are going to be export for the another countries for the economy. And also these electric vehicles they are going to be expected for the 2050 in the aviation field and iron and steel field and the marine field. The generated hydrogen systems they are going to be enhanced in particular fields and in particular sectors. And the Southern America, the Latin American goals also pretty defined, and they are focused and following the top-notch nations. They are going to enhance the 1 gigawatt of the electrolysis capacities by 2025, and also they are going to generate the world cheapest green hydrogen by 2030. And the Chile is the country which ranked about the top third exporters by 2040 is their one of the primary vision. With this primary aim and vision, the country developments with the policymakers and also the industrialists. And followed by the same path from the Chile, the Brazil is the nation which they have announced the hydrogen program PNH2. So it emphasizes the green hydrogen using the hydroelectric and grid-wise abundant with wind and the solar energy. So they are going to be electrified and also grid level based systems by the next coming few years. And also the country is having the goals to have a collaboration with the 10 megawatt pilot green hydrogen plant by using the same Colombia roadmap. By they are going to use by they have started from in 2021 in the hydrogen roadmap series, and the goals was is pretty clear and pretty sure. Generation and establishment of 1 to 3 gigawatt of electrolysis capacity to be reached by the 2030, focusing on the both green and the blue hydrogen for the industrial. Blue hydrogen can be used for the industrial utilizers, industrial products, and the green hydrogen can be used for the exportation of the fuel needs and the substantial needs for the energy consumption needs. And coming to the Europe hydrogen strategy, the European Union, Germany, like France and Denmark, has also launched their initiatives in 2020 itself. They're also aiming for the 10 metric tons of the domestic production of hydrogen, and also they are going to complete this initiative by 2030. And also the European hydrogen systems are also giving for the enhancement of the subsidized, and also they are going to the government initiatives are also giving for the subsidies for the present market. And also the Germany is also one of the many Nobel laureates from the German nations are also working on for the national hydrogen strategy, which was launched in 2020, and they have updated their launch version in 2023, and they targeted for the 10 gigawatt of the electrolyzer capacity by 2030, which was like a 9 billion funding they are going to be initiated, and which is they are going to be monitored and going to be complete by 2030. In the same path, the France is the country almost like 150 million green hydrogen plants, which was they have initiated in 2019, and they are focusing the infrastructure and the production, storage, distribution by using the local transport applications. And this corridor, the Green Channel corridor, was initiated by for the enhancement of the hydrogen economy, and also the network connecting for the France to the North Sea, and also this for this funding almost like 40 millions of the supportive methods was been launched from the European Council. And the same path, the Denmark is the country which is going to be tender about 6 gigawatt of the electrolysis capacity by 2030, emphasizing the technology with the company called X Technology. And also coming to the Middle East, like North Africa, the Saudi Arabia, UAE, Oman, and Egypt, all the four countries are also visioning the same path by 2030, establishing like 1 to 6 gigawatt of the hydrogen storage plants. And also coming to the UAE, they are having a versatile roadmap by demonstrating by 2031 they are going to be established like 50 metric tons by 2050. Also, they are going to be facilitated by generate the hydrogen gas plants, and also the many R&D initiatives, and also inviting the global partners to fulfill this achievement. Coming to the Asia and the Pacific region, we begin with Japan is the first nation of the hydrogen strategy, begin in 2017, planning the robust adoption of using the 21 billions in subsidiaries for giving 21 billion subsidiaries for the clean hydrogen. And for this financial budget, which lasts for 15 years, like up to 2023, and also they are continuing this support for as of 2024, like they are going to give the the technological infrastructure for almost like 157 countries, and also they are going to give for 157 hydrogen fuel stations, which is they are going to be established by 2050. In the same path, the Australia is the country which they have the industrial policy for the 2024, which includes that renewable hydrogen among the top 5 priorities for industries. With the support of the schemes and the domestic investments, they are going to do like 5 to 6 gigawatt of the charge stations by 2050 is the one of the crucial strategy they are going to be initiate. And coming to the since I am from currently I'm working in Taiwan, so I would like to disclose about the Taiwan green hydrogen policy and the roadmap. So they are going to target many countries. Following this, like many countries, Taiwan is going to be one of the role model among the all other countries. They are going to targeting like net zero carbon emissions by 2050, and for to achieve this goal, hydrogen is identified as a key pillar for renewable energy source in compare with other renewable energy sources. So the development has begun from the beginning of the 2022, and they have demonstrated the projects like fuel cells, natural gas, and hydrogen based buses. And they are going to cooperate with the R&D systems with the academic. Seneca is an academic institution, and the ITRA is a company, and NAR labs and universities. They are going to cooperate to reach these goals by initiating the several R&D projects and the pilot projects. Some of the pilot projects which are already launched in Kaohsiung and Taichung and other industrial hubs. And there are some industrial corporations, like for example, Taiwan is having the strong strategic industrial cooperation with the Japan, European Union, as well as United States for the technological and exchange for the hydrogen technology. And also the country is going to have the exports and imports with Middle East countries like Saudi Arabia, UAE, Oman, Qatar, and Kuwait, and Iraq and Iran. And some of the North African countries like Egypt also, the country is having the export exports and imports for the traditional renewable energy systems. And coming to the India is aimed to produce like 5 million metric tons of the green hydrogen annually by 2030, which was supported by the 125 gigawatts of the renewable energy capacity. And this is like a 2.4 billion in funding almost. In recently, the pilot scale projects was the first port-based green hydrogen project, which was launched at VOC port, and the power streets like electric vehicle chargers, and the part of the wide range of the clean energy efforts. They are going to integrate with the hydrogen-based systems, and this was launched recently on September 5th, 2025. India is also engaging several and versatile R&D projects to make green hydrogen as one of the most economical and viable transport mode, which is going to be looking for a bright future in this sector. And there are like versatile collaborations with the European Union on green hydrogen under the trade agreement of free trade agreement is going to be initiate to diversify the funds and also to enhance the sustainable approaches in the country. The famous company in India, Reliance Industries, also going to be take a charge on to be part on this sector to make a significant transition from non-renewable energy sources to renewable energy sources. As a part of that, green energy strategy is one of the systematic strategy that believes to bolster the India's energy self-reliance. And also this is the slide which you can going to understand about the state-wise the hydrogen energy initiative projects that which has been launched and which are currently under progress. As of now, you can see the majority of the states are dominant with their technological era to be in the part of the sustainable energy sources. As a dominant state like Gujarat is going to be launched the 8 hydrogen sustainable power projects, which is going to be already launched and going under progress. And this is going to be a function and also be committed to complete by 2030 as well as 2050 is the next target goal. And followed by the states like Madhya Pradesh and Maharashtra and Karnataka, and also Telangana and Andhra has also been initiated the several hydrogen energy projects and these hydrogen energy corridors to encourage the investors and also to encourage the young entrepreneurs to be on this part and also to move the nation into the first stepping stone for the sustainable energy approaches and also competing to the world economies. As I told, all these discussions in the previously, the same content has been repeated in this slide. And the very interesting was the hydrogen power trains, and which is going to be initiative. The central cabinet ministers are also been recently launched on August 12th. The minister Ashwin Vaishnaw also shared one of the video. They are going to launch India's first hydrogen power train, and which is already the signaling was already ready and it is also launched. And not only it was launched, the first trial run from the stations like Jind and Sonipet route around like 356 kilometers round trip has also been selected and the trial was also completed. It's a 10 coach train which is the covering about the 2,600 passengers. And if this project is going to be successful with all preliminary checks and all the majority of the desks and India's complete sustainable energy, it is the beginning stepping stone to be the country, to be the nation, the first nation in among other countries to establish the hydrogen powered trains, which can be run all over the India and also be the technology can be also transferred from the world other countries, which is a key significant part. The ranging from the India is the becoming a fourth largest economies to the number one, the biggest economy. So this is one of the first initiative India can take charge that can able to progress its economic traits and also be the supreme power in the next coming years. And these are about my conclusions that which I have given the talk on net zero carbon emissions, why we need to do the net zero carbon emissions, and how we are going to give the check power and why we are going to give the CO2 emissions, that is, which is one of the critical phase that we are going to challenge, and what is the energy security for the 9.5 billion population. The energy security and energy needs are at priority. That because of that 1.3 billion population issues, we are purchasing the oil from the Russia. It is the energy security issue that we need to keep in our mind for the next future generations. And also we have to work for the global investments and also technological awareness to enhance this technology for the next coming years. And the career opportunities that I would like to discuss about the green hydrogen and the sustainable energy routes, that Taiwan is also one of the best and suitable country in Asia. And most of the people, most of the universities, they offer the masters in the sustainable and the green energy technologies. The famous and the national universities, the clean atmosphere universities, they are going to give the versatile courses on a masters in the sustainable and the green energy. And the first one is the National Central University, and the second one is the National Chongqing University, and also another universities like NTNU, NTU. All these national universities which is having the QS ranking, the world less than 200 ranking, the world QS ranking, all of them are like below 200, which they can give the wide research abilities and opportunities to pursue their future masters or PhD as well, with 100% tuition fees waiver, and also for the students enhancement, many R&D projects and also internships are also will be available to make the students future as the bright and make the younger minds which they can build the nation of Taiwan, India, as well as the rest of the world. And I would like to acknowledge the different departments, those which I have passed through. Since I need to thank for the Department of Science and Technology, where my master degrees has happened. And I would like to thank the NSTC, National Scientific Council, and I would like to thank my center, and I would like to thank my national universities where I have done my PhD, and I would like to thank the Changsha University where I am working. And special greetings to Dr. Bapuji Saunke Institute of Engineering and Technology, which they have conducted this opportunity to meet you, the young students, and to meet the young entrepreneurs, to meet the outstanding teachers on this special event. I really thankful for you all. Thank you. Sir, are you there? Hello? 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 Is anyone there? If you have any queries, you can unmute and you can ask.
If any questions, please ask.
Okay, sir, then can we conclude?
Yes, sir. Yes, sir. I hand over this session for vote of thanks for the Mr. Brahmaran Dev, sir.
Okay.
Hello. Hello, Vajja sir, I am audible?
Yes, sir.
Yes, sir. You are audible.
Yes, sir. Okay. First off, good evening, everyone. As we come to the conclusion of this faculty development program, it is my privilege to propose a vote of thanks on behalf of the organizing committee First and foremost, I extend our sincere gratitude to our resource person, Dr. Srinivas sir, for sharing their valuable knowledge, insight, and experience throughout this program. Your contribution has truly enriched us and provided a new perspective to enhance our teaching and research practices. I also wish to thank our respected principal sir, management, and coordinators for their continuous support and encouragement in making this FDP a success. A special word of appreciation goes to all the participants. Actively involvement and constructive discussion have been the real strength of this program. Finally, I thank all the supporting staff and voluntary whose effort behind the scenes ensured smooth conduct of every session. With this, I formally declare, sir, any uh, this program is over or any hello.
Yes, sir. We conclude the session.
Okay. With this, formally declared the faculty development program successfully concluded. Thank you, all of you.
Thank you so
Okay,
much,
sir.
sir.
Okay, sir. Thank you so much.
Okay,
Thank you,
bye.
sir.
Thank you.
sir.
Please left the meeting.
A nice FDP conducted.
Yes, yes. Thank you, sir.